So the last group of problems, they're not hard, but they're different, and they're the connection between the first section and the next few sections. It's factoring out when you have a common parentheses as a common factor. I wrote down a problem to rewrite by factoring out the common factor from this ugly, I don't even know if I'd really call it a binomial. Let me figure out what the common factor is between this 12x times x minus 5 and this 7 times x minus 5. So I'm going to look at the coefficients of 12 and 7. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. The factors of 7 are 1 and 7. The coefficient common factor is a 1. I won't need to worry about it. Next to the 12, there's an x written without a parentheses. But after the 7, there isn't that x. There's not going to be a x to some power part of my greatest common factor. So there's not a number I need to factor out because the greatest common factor between the 12 and the 7 is a 1. There's not a single letter I need to factor out because there isn't a single letter right after the 7. But there is a common parentheses. And that common parentheses, kind of with the parentheses, is going to be my common factor. Both my common parentheses have an exponent of 1, so the exponent would be 1. So how do I factor out once I know a common factor? If I've never done it before, I write the common factor in front of a parentheses. Then I'm going to take the original problem, in this case 12x times x minus 5. Lead it off with my parentheses, put that in the numerator of a fraction, and in my denominator, write that common factor out front. Now I can cancel, and be left with a 12x to lead off my parentheses. Next term was 7 times x minus 5. Figure out what's left in the parentheses when I factor out the common factor of x minus 5 by forming the fraction that's needed, canceling out the common parentheses. I claim that this is my answer. These are dumb to check because I don't know that I could check it in a way that you're going to be happy with, but here's how you're going to have to check it. You're going to need to rewrite the original problem, clear the parentheses and combine like terms, rewrite my answer by foiling, and make sure that the original problem and my answer reduce to the same trinomial. I'll have an awkward time to try to make my answer equal the original problem in its form. So what I did is I took the original problem and cleared the parentheses. The first parentheses, I did 12x times x and 12x times negative 5. Second parentheses, I did 7 times x and 7 times negative 5. Did the multiplication, combine like terms, rewriting the original parentheses by clearing the parentheses and combining like terms, I get that. Then I just said take my answer and rewrite it by foiling. So I did x times 12x, x times 7, minus 5 times 12x, minus 5 times 7, did the 4 pieces of the foiling, cleaned up the terms, combined them, and they equal the rewrite of my answer and the rewrite of my original problem are the same, so it checks. That's how we would check these. They're really clunky to check. In terms of being efficient, it's super easy to do this factoring without doing this much technical work. This is the proper way to factor, but in practice, it's not the way I'd ever factor these. Super easy to factor these without showing gobs of work. If I look and see a common parentheses in a problem, that's likely the common factor, and that's going to be the case here. The common parentheses is the common factor. I'll do 40 properly and then 39 lazy. So for 40, I look at the coefficients. The first term has a coefficient numerically of 1. The second has a coefficient of 2. And between the factors of 1 and 2, the GCF is 1. I'm not going to factor out a 1. The first term had an x in front of a parentheses. The second term didn't have an x in front of a parentheses. There's not going to be a common factor of an x. But both terms have a x minus 5 to the first power in common as a factor. That is what I'm going to write in front of my parentheses. So I'm going to write an x minus 5 inside its parentheses. And then I'm going to figure out what to fill in the parentheses with. I'll take the first term, divide it by the x minus 5 that I wrote out front. And now I'm going to cancel the x minus 5s and be left with an x. I'm going to take the second term, not changing any signs because I'm not factoring out a negative, so I brought the plus sign in, and divide it by that common factor that I wrote out front, and that's going to leave me with a 2. The answer to 40, which would be clunky to check, is that. And how can I get that answer? It's so easy. The common parentheses I write first, and what goes inside the common parentheses is what is in front of the common parentheses. Let me formalize that with problem 39. When I see a common parentheses, I write the common parentheses, and to fill in my second parentheses for my factoring, what's in front of the common parentheses will wind up filling up that parentheses. So in the second parentheses that I've written, I get 2 parentheses because the common factor is a parentheses. I'm going to put the x that preceded the first x minus 4 and the plus 3 that preceded the second x minus 4. That's the answer. They're just that easy. Write the common parentheses, then create a parentheses, and inside the parentheses you write what's in front of the common parentheses. So for 42, I see the common parentheses. I'm going to write down the common parentheses and then make a second parentheses. Inside that second parentheses, I write what's in front of the common parentheses. In front of the first x minus 4, there's an x squared. In front of the second x minus 4, there's a 5. That's considered completely factored. It's checkable, but it will take me longer to check than it would be to do the rest of the problems in this section. 43, just because it's hard to write so low on my screen, the common parentheses is z plus 1. To finish up my answer, what's in front of the first z plus 1 is a 3y. What's in front of the second z plus 1 is a minus 4. That's considered completely factored. There aren't going to be any extra common factors here to fuss with. 46, common parentheses of 5x plus 1 with an exponent of 1. I made all the common parentheses have the same exponent because that's what's going to happen later in the chapter. It could theoretically have a common parentheses and one has an exponent of 2, the other has an exponent of 3, then you'd have to factor that out with the appropriate exponent. But that's not a skill that's necessary for later in the chapter, so we won't fuss with that variation of these problems. 47, common parentheses, followed by what's in front of the common parentheses. Super quick, super quick problems, but super important because it's kind of the that's the connection between this section 5.1 and section 5.2, and it's the connection between 5.2 and 5.3 and so forth. It's a real important skill. It's not much of a skill, but it's important. So I just wrote down the answers without saying a word. Hopefully you're able to follow what I did. Master this skill before you move on to section 5.2, because this skill is going to show up in every problem. All right, sorry for the four-parter.